Hey there, thank you for joining this session on using Ansible to deploy on top of OpenStack. I'm Tony Dubiel. I'm a cloud architect working for Cisco. I'm also a CCIE and route switch, data center, and a voice. For the past few years, I've been spending a lot of time focusing on cloud and more recently on OpenStack. So I thought it was a good idea to start to share some of the knowledge and skills that I've been building using toolsets like Ansible and some of the knowledge around admin and other skill sets that are needed to manage a customer's OpenStack environment. The core purpose of this two-part demo series is to first highlight the power and ease of use of Ansible, which is primarily used for orchestration and automation. It's a configuration management tool. It's also a deployment tool used for installing software. This demo will definitely offer you some tips and tricks, specifically how to use Ansible, but it's certainly not intended to be an exhaustive tutorial on Ansible. The second part is Metacloud, which is a Cisco solution. It's remotely deployed and managed. It's built using OpenStack, and it provides APIs, which are really important for these types of tool sets to orchestrate building environments. And it provides, secondly, it provides self-service, which is ubiquitous across the compute, network, and storage. So as you are probably aware, deploying apps is no trivial task. And this is certainly a representative sampling of many of the tasks that IT teams must come together and determine the best tool set and the approach for building from scratch a tenant environment, the network, as well as the DevOps components, which are deeper into not only the virtual machine or containers, but also the applications themselves. And if there's code that's being built, then there could certainly also be, on top of all of this, a CI/CD component of a tool chain for the life cycle of the code as well. So again, this is a two-part series. So this current demo will focus on two personas and roles, the cloud admin and the network admin. In some cases, that's the same person. It could be a handoff between multiple individuals as part of a workflow within IT. But the goal here is to certainly highlight how easy it can be to take an OpenStack. Um, in the case of Metacloud, it's fully functional and delivered to a customer, ready to use out of the box, if you will. And it's a handoff to a cloud admin. The cloud admin is the individual that would add users, create projects, set quotas for the users and projects so that they don't overconsume resources, as well as giving the ability to end users or on behalf of the users uploading images, which normally that does happen. A cloud admin would make certain cloud approved cloud images available for those end users, and create other environment types of access to platforms and hardware purpose-built in some cases for certain types of applications. And that's where things like aggregates, host aggregates, are used to make sure that a virtual machine lands on the proper hardware. So those are just a sampling, again, not an exhaustive list of some of the tasks that a cloud admin would certainly be interested in automating to make it very easy, repeatable, and delivered very rapidly for an end user. The second piece is a network admin, and OpenStack provides APIs through the Neutron service. It's very slick in the way that you can use leveraged APIs for programmability of the network. So for building virtual resources within the construct of Neutron, you can take advantage of programmability to build your virtual routers or virtual networks. You can create floating IPs, which are public IPs that are used for external access from the internet to your OpenStack cloud environment, to those virtual machines that could be public web servers, as an example, or load balancers. And then other constructs, such as security groups, which you can build and certainly should build to protect those virtual machines in these environments. The next demo that we'll focus on in the subsequent demo video is more of a drill down into what the DevOps team would use. So typically the cloud admin, network admin, these admins are creating the projects and making resources available. And then there's a handoff to other teams that are building environments. An example of an environment could be a dev environment, a test environment, staging, production. And in these environments, these teams may not have the underlying skill set, the specifics on how to build the network or to build the particular projects, but they need those resources. So they're consuming certain resources, and then they're primarily focusing on the actual virtual machines or containers and the applications, and updating those applications and deploying those applications, and hooking these applications into a CI/CD tool chain, for the actual lifecycle management of code deployment and building code. So we'll go ahead and transition from here to the actual demonstration, and I hope you enjoy. Currently on your screen, you see the dashboard of Metacloud. This is the enhanced Horizon dashboard. A listing of projects will demonstrate that we haven't built a project called demo project. So these are the actual projects that have been implemented on this particular Metacloud trial environment. And just to prove that from a command line as well, we'll list the projects out, and as you can see, it's the same ones here or the same ones there. So before we build a new project and add components and resources to that project, I kind of want to give you a quick rundown and high-level overview of Ansible. So Ansible has been installed on this particular jump box, which is an Ubuntu virtual machine. It's a newer version of Ansible. So let's take a look at that. We can see that it's Ansible 2.2, so fairly current version of Ansible, which means that it gives me access to the newer OpenStack modules. So there's kind of like the older versions of the modules that are available, as well as the newer version 2 modules. And the purpose of the modules are to make it a little bit easier to deploy into OpenStack, because essentially templates have been made into modules that I can point to from playbooks. So I'll explain what playbooks are here in a second, but essentially it just makes it easier. If a module isn't created for you, then if you have the skill set, you can certainly build a module and you can actually contribute back to Ansible, or you can use shell commands, in this case the OpenStack command lines, like I just used here. This is an example of an OpenStack command line. These are the newer ones, the OpenStack commands. I could have used some of the older ones. Here's an example, like Nova list will show virtual machines. I can do OpenStack list, which is the newer syntax. Oops, I think it's server list. Yeah, so basically similar commands, just different syntax. Eventually the older command line will be deprecated, but for the meantime you can use either one. Again, I'm using newer modules which are actually leveraging newer OpenStack APIs from Ansible. And there's also one other dependency to point out, is that you need to have Shade, Python Shade installed on either your laptop or a jump box that you're using to configure Ansible. So Ansible has some requirements. One is you have to have a host inventory. Typically that is installed into a directory by default, but you can actually install the host inventory wherever you want, as long as you point to it from either the Ansible config file, which we'll look at here in a second, or when I'm executing an Ansible playbook command, I can use the -i argument, and I can tell it what host file that I'd like to use from the command line. So in this case, we're using the Ansible config. So we'll just go ahead and take a look at that real quick. And this allows you to override some of the defaults, and one of those being the host file. So I'm pointing to a host file that's actually in this directory, and we'll take a look at that. And you can see that all I have populated in this host file is localhost. So what localhost actually means is that when you execute the Ansible playbooks, you're executing them from the local host where Ansible is installed. And in this case, we're pointing to an API. So we also have environment variables that I've already authenticated that tell the actual OpenStack clients that we're using, that the modules are actually using, to point to an OpenStack, which happens to be a Metacloud trial environment. So I can actually show you that real quick too. So we're pointing remotely to a remote OpenStack, but we're executing the commands, the OpenStack command line commands, from this local host where Ansible is installed. Now in part 2, when we transition into the platform DevOps level types of tasks, we're actually going to use an additional inventory where we're pointing to virtual machines that are hosts. So we're pointing to IP addresses or DNS names of external machines that we want to remotely connect to using SSH, and then either configure by installing software or updating software. We'll demonstrate some of those activities and how we can leverage Ansible for remote virtual machine configuration management as well. Okay, so let's go ahead and the auth file, I called it auth. As you can notice here, we have an environment variable, export, osauth URL. This is the actual URL that points to the Metacloud that I'm using, this trial Metacloud that I'm using for this demonstration. And this is the API for authenticating to that cloud. There's also my credentials and other things that I won't show you in this file, but this is basically how we're remotely pointing to the Metacloud trial pod. The next thing that's key is the actual variables that we'll use for our Ansible playbooks. So I'll take you into Ansible playbooks to give you some examples of the syntax and those OpenStack modules that I previously mentioned. But a big key to this is that Ansible playbooks are made to be repeatable and easily repurposed and very modular to be used and reused over and over again. And the way that this works is much like any other programming methodology where we separate our variables from the actual code. So variables are very important. We'll go ahead and take a look at what we have here in terms of variables, and then we'll take a look at the actual playbooks, and then we'll execute the playbooks for the demonstration. Okay, so you'll see that these variables will be called in various playbooks. So no need to go into too much detail on this particular file other than that this is the file that we're pointing to. And there's a bunch of information that will be invoked as we go through parameters, and those arguments will call upon these variables. And this is what we'll see actually provisioned in our OpenStack. So some categories here that are important and worth mentioning are But we're going to upload an image. So this is the particular image and the name of the image. We're going to modify our quota. I mentioned that a quota is really like a guardrail around, you know, allocating resources, but not allowing any particular user to oversubscribe resources from the system. So in this case, we're limiting and creating, a threshold of resources that they have available to them in their project. The actual host aggregates that I mentioned, we're going to implement those for web servers, and we're creating a custom flavor. A flavor is much like an instance type if you're familiar with AWS. An instance type is the size. So in this particular flavor, we're actually making a custom flavor which limits the amount of RAM, virtual CPU, and disk to what we build for a virtual machine that is leveraging that flavor, and then we're mapping that flavor to a host aggregate, which would dictate what compute node that VM could run on, and in this case it would be for a web server. This is more for the second demonstration, but this is clearly a demonstration on how we would initially set that up for a handoff. So Cloud Admin would build these constructs and then make them available for the DevOps team to deploy their environments into those projects. We could create volumes for storage, for attaching a database as an example. In this particular demonstration, we will build a router and we will create a network for that router. And there's also a subnet here at the end, and we'll create a subnet. So we'll see all of this again, and I'll make sure to point this out as we go through the demonstration. Okay, so the other thing is playbooks. Normally, it's best practice not to have a gigantic playbook with multiple tasks. So typically, you break it down into a more module implementation by creating multiple playbooks. Then you kind of stitch them together in a main playbook. So that's what we have here is a main playbook that I've called demo create. And you'll notice that these are YAML files. So this is the syntax that we use in Ansible. And a main playbook is really just including other playbooks. So I'm aggregating these playbooks together, and they would be implemented one by one when we launch the Ansible playbook of the demo create. So we'll go ahead and change directories here into playbooks create. These are all the individual playbooks that we just looked at, and we'll go ahead and we'll walk through them so you can get an idea of the modules for OpenStack and some of the tasks and other work that I had to use using the command line, the shell commands, and and other techniques that I use to build this out. So the first thing was creating the tenant or the project. So we'll go ahead and walk through this one. So one of the things that we have to do, as part of a YAML file for a playbook, is we have to name it. And when you execute the playbook, you can see the name of the playbook. So it'll be called out as a play. And what I like to do is go ahead and list the file. So that way, if it has an error, I know what file to go look at right away. So it makes the debugging a little bit easier. And then I also name like kind of the high-level purpose of what this playbook is doing. And then the next thing we do is we have to point to the host file. So in this case, it's local. So this is a tag here that within the host file, we're looking for just the local host. Now, if we were pointing to other external, inventory of external devices, then we would create, tags for that as well. Like we might call them web servers or app servers or databases, and we would want to point to them in the host file. And in the second lab, you'll see examples of that. Okay, so another important aspect is we need to point to where our variable file is, and that's what this is. So that's what we just looked at. So some of the variables that we walked through, we're actually implementing them and invoking them, from this playbook. So task. So you can have multiple tasks within a playbook, but it's really best practice to kind of limit, that to a reasonable amount so that you can troubleshoot these. So here is the name of the task, and you'll see the task will be called out as we invoke these playbooks. So it'll say play, and it'll say task. We'll see these names, and this will scroll across the screen, and you'll see this again. And this OS project is actually a module, an OpenStack module. So what this did was it actually simplified the commands that I need to build the new project or tenant. And the state present means that if it's not already built, go ahead and build it. And then absent would dictate if it's there, delete it. So we'll see this in reverse order. We're going to invoke playbooks to build our environment, our project rather, in OpenStack, and then we'll do the reverse to delete the resources in the project. This is a variable, the tenant name. It is called demo project. That's what we named it in our variable file. And then this is just a description of the project. Now this second part of the task that we have here is I wanted to add a user to the project. Now there actually was a module for this, but for me it actually was a little bit simpler just to use the shell commands. So again, a shell command is the OpenStack commands, and what you notice is that this says OpenStack. So in the older version of the OpenStack command line, this would have been Keystone, but I'm using the newer OpenStack commands. So it's OpenStack, role add, user. This is the variable user. The user is actually AN Dubio, which is my account on the trial pod, the Metacloud trial pod that we're accessing. And then the project tenant name was demo project. And then admin means that we're giving that user admin access to this new project that we're building. The next thing that I wanted to do was to display the default quota, because one of the other tasks that we will implement after we build the project is we want to modify the quota so that we can increase the amount of virtual machines and memory and and other resources to make more resources available to this particular project to demonstrate how we can change the quotas. We can either increase or decrease the amount of resources. So having said that, we'll go ahead and look at the quota update. So in this one, we're listing out the list quota. Yeah, we're listing it out. And then a little bit farther down here, we're updating it. So instances was the amount of instances. And these variables were in the variable file. So I think it was 200 instances. And I don't recall how many virtual CPU cores and RAM and so on. But we'll see this when we go back into the GUI. We'll take a look at this. And then we display this. Now, one of the things that that I did is I wanted to see it on the screen as we're actually implementing these commands. We can show them displayed on the screen, and we'll see this output on the screen. So that output will be in blue, and it'll stick out from the other Ansible playbook output that we'll see. So we'll see plays, task, and then we'll see these debug messages, a specific output that I want to see on the screen as we're invoking the playbook. All right, so the next thing that we had is we wanted to upload an image. So again, we point to our variable files and so on and so forth. So this is all the same. This is primarily a requirement that we have in all of our playbooks. So in this task, we're implementing another OpenStack module, so OS image. So here we have to give it a name. So the image name, we're assigning it to our project, our new project that we're building. And then the actual image, we have to identify the format of the image. So in this case, it's raw, which works well in a Ceph storage environment, versus other image types like QCal or VMDK or ISO images. This particular image, we're uploading it as raw. And then this present means that if it's not already uploaded, go ahead and upload it. If we change this to absent, it would actually delete that image, and we'll see that in a reverse order when we go through our other set of playbooks to essentially wipe everything out, to clean up what we've built at the end of the demo. And then this is the file name. I think it's called demo image in our var file. And then there's some bug with this particular module that hasn't been fixed yet, where it doesn't make the image public. So if it's not made public, I can only use this image in this particular project, the project owner, but not be able to use this image in any of the other projects. So if I want to make it public, then I can go ahead, and in this case, my workaround is I used an OpenStack command line. So OpenStack image set public from this project, which was the demo project, and the image name. And we'll be able to verify this afterwards. We can see that the image is public after we upload it. Okay, so the other thing that we are building is the network. So we'll go ahead and take a look at that. And again, we're leveraging the OpenStack modules. Very simple here. We're going to build a network, a subnet, and then ultimately a router, and attach the network of the router. Let me scroll down here so you can see that part too. Yeah, so we can see this is pretty much everything. So again, building a network. If it's there, build it. If we do absent, it would delete it. The private network is actually called priv2 or priv2 in our variables. This is the project, the demo project. And then for a subnet, it's the network is the same one, priv2, and then we'll call the name of the subnet priv2, and these are all in the variable files. And then this is the actual subnet that we want to use. I could have made this a variable. I just went ahead and hard-coded it. And then our DNS server. This is just using Google as DNS, so that way we can resolve names as we deploy virtual machines, which we will do in the second part of the demonstration. And then we're going to build a router, and the router, again, present, build it, absent would delete it. The router name is demo router. I think it's demo underscore router. And the project, demo project. And then priv sub would just point back to this subnet that we built here. We're going to attach that subnet to the router. So we have a private network that we attach. This network here is the public network. So the private network is on the back side of the virtual router. On the front side of the router, it terminates to a public network, and then that gives us external access out of the Metacloud to the external public network. And then we would be good to go. So again, we're going to build all these things. We're going to see it on the screen as we build it. And I'll go ahead and invoke the main playbook, which in this case was demo create. Let me go back. Yeah, demo create. So Ansible playbook. I don't have to tell it the host file because Ansible config already knows to point to this host file that we see on the screen here in the same directory. So I just need to say demo create.yaml, and then we build. In blue are the things that I went ahead and debugged the output so we can see it. We can see that here's a playbook and then the task of that playbook. And then here's output that I'm asking for. Playbook, task, task, another playbook, task, 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 output that I'm asking for. This is all building flavor to host aggregate task. This kind of goes kind of fast. Here's the router. There's network, subnet, playbook creating the router. And this here shows that It completed 28 tasks. Some of them were just, hey, display information on the screen. And it actually changed 20 items, which were things that we were asking it to build. So now that we've built this project, we can go ahead and make sure that it's there. Right, it's demo project. We built a host aggregate, so it's easy to look at it from here. So I'll go ahead and do Nova aggregate list, and we should see a web ag right here. This is an ID that it assigned to it. There's also a flavor that we created. It's where's it at? Demo large. That's the one that we created for this specific size. And then we'll go ahead and take a look in the GUI. It's a little bit easier to see some of the other stuff. So we'll go ahead and log out and log back in, and we should see the new project. Because it was built under my username. So we drop down here, and now we can go into demo project. We can go ahead and look at the network. Start there. We can see we have a router, and it has an interface. Right, so let me get that out of the way. Priv2 is the network that we built. And then we built the Priv2 subnet with the 10.6. Right, so these are internal interfaces attached to the router. DHCP is so that our virtual machines can receive IP addresses. So that service is actually consuming a port. And then you have the router interface on the private network, and then also an HA interfaces for HSRP for redundancy. So that's another advantage of Metacloud, is that we use ASR routers, physical routers, that we're building virtual routers using VRFs in the Neutron plugin. And that allows us to have redundancy with an HA interface for that private network. Okay, so some of the other stuff that we built, I'll go ahead and expand the project, and I should see the image that we uploaded. Yeah, demo image. And remember, we made it public, so we can actually see that it is public and that its format is raw. And what else? Oh, we made that flavor. That we already looked at that, but we'll just go ahead and look at it from here just to show you. Demo large is the flavor that we made. And okay, so now that we've validated that we've built this environment, this project, let's go ahead and delete it. So in the reverse order, let me go ahead and show you a couple of things. We'll go ahead and look at the tenant. Oops. Now remember, we use some of the OpenStack modules. So this particular one is for building a project, but also deleting a project. All we have to do is say absent, and it's going to remove that project. So we'll go ahead and go back. We've got demo delete. Oops. Demo delete. And it's just like the demo create. We're calling several playbooks, and each one of them has the responsibility of deleting a particular resource that we built when we established the initial project and built all these components. You see playbooks. task, playbooks, task, deleting everything, changing the quota back to the way that it was previously. Removing that aggregate. Okay, so now we have 17 because in blue you can see that I listed some stuff out, but we've changed 12 things in order to delete everything out of there. And we'll go ahead and make sure that it actually is removed. You see, no demo project anymore. Now here, what will happen is we'll start getting some errors because we removed that project, right? So there's really nothing in here. Here's the error that I'm talking about. Oh, this was the quota. I forgot to show you the quota. How we upped it to 200 instances, CPUs, and so on. So what you need to do is, if you're logged in to that project, when you sign out and sign back in, you won't get those errors anymore because it'll be removed. And you won't see it anymore. See, I can't even, there is no demo project anymore. So that's basically it for the main components of building a project and how easy it was to not only build the project using Ansible, but to remove it, right? So my cleanup, perhaps we have a very disposable environment that we're building and building and tearing down projects for particular teams, over and over again. It's very easy to build and then hand off, and then when they're done, go ahead and delete everything back out. We can script all of that, make it very automated, very easy and rapid, tasks to build or tear down. Again, just the value there. So in part two, in the next video, we'll focus more on once we have a project, how easy it is to bring up virtual machines or virtual machines and containers and install software and update applications and so on and so forth. We can automate all of that to make it very easy, for those teams as well, the DevOps teams. So I hope you enjoyed this demonstration, and stay tuned for part two.